All right, Ozarka here. We got another video about lines. In this case, it's going to be equations of lines in special forms, section 2.3. We're going to be doing all of the following for the section objectives. Find and apply slope-intercept form of an equation of a line. And the same token, find and apply the point-slope form of an equation of a line. Semi-related, just looks a little bit different. We're going to graph a line using its slope and a point. We're going to find lines that are parallel or perpendicular to given lines, kind of similar to the last video. And 5, apply lines and linear equations to real-world applications. We're just going to do an example problem with that, just to kind of show how you can use this stuff in the real world. All right, here we go. Point-slope form. Suppose a line has a slope m, and it passes through x sub 0 and y sub 0. Then for any other point x, y on the line, it must be true that the difference between those 2 points is equal to the slope. And if you wanted to, what you can do is you can actually multiply both sides by this right here. If you do that, you're going to end up with y minus y sub 0 equals m times x minus x sub 0, which is essentially the equation that they have right here. Okay. So basically it means the same thing. If you use the slope equation, you multiply that denominator to both sides, it will cancel on the left, and then you have m times the difference of those x's, x values. That's essentially where point slope comes from. If we think of x comma y as a variable point on a line, these expressions give us equations of a line. So now you have an equation of a line that if you use that line, you could find a bunch of points, and then once you have those points, you can make a line. You can connect the dots and make that line. So that's basically point slope form. Let's do some examples. So example 1, it says find an equation of a line with slope -5 and passing through that point right there, 2, 3. So to do this, I'm going to start by setting up the point slope formula. So it's going to be y minus y sub 0 is equal to the slope of 5 times x minus x sub 0. Now the x and y sub 0, the x0, y0 point there, all you have to do for this is plug in the values that are given. So it's going to be y minus 3, so I'm plugging in the 3 because of the y there, is equal to 5 times the x minus the x that's there, which is the 2. So this right here would be a possible answer for the equation of the line here. It's in point slope form. It doesn't actually specify which one to do, so I'm just going to do the easiest possible one, which usually is point slope form if you're given the slope and you're given a point. So I'm just going to kind of keep the answer like that. Before I go on though, I just noticed that it's -5. This is why it's always important to check your work, especially when you're making videos super early in the morning. All right, number 2, it says find an equation of a line passing through those points, write the answer in standard form. So one thing that I want you to notice, the difference between number 1 and number 2, is number 1, it gives you the slope. It says, bro, the slope is -5. Number 2, it does not give you any slope, which means you have to figure out what that slope is first, and then you can actually use this to find the answer. It does say find the equation of a line, and then it says write your final answer in standard form. So we are going to have to put that in standard form at the end. We are going to want to try to remember that. All right, so the first thing we're going to do is find the slope, okay, because it's not given. Again, number 1, it says the slope is -5. Number 2, it doesn't, so we have to figure out the slope. I'm going to do the second y minus the first y divided by the second x minus the first x to figure out this slope. You're going to have 3 on top and -4 on the bottom. So our slope for this one's going to be -3/4. I'm going to put this in point slope form using either of the points. I'm going to do 1, 4 because it's a little bit easier. There's not a negative in there. I'm just going to go with the easy route. So I'm going to do y minus 4 is equal to the slope, -3/4, times the quantity x minus whatever x was given. So that right there is in point slope form, but it says that it wants the final answer in standard form. So first thing I'm going to do is actually get rid of that fraction. So I'm going to multiply both sides by 4, which means I'm going to multiply everything by 4. And this is going to be like that, x minus 1. Okay, and if you remember, standard form has to have that like ax plus by equals c format. So that's what I'm going to look for right here. Let's distribute that right side. It's going to be -3x plus 3. Okay, I'm going to get the x's and y terms on the same side, so I'm going to add the 3x on both sides, and then I'm going to add 16 to both sides. From there, we are in standard form, so that is the final answer. Just use some basic algebra to get it in that standard form. So the x's and y's are on the same side, everything else is on the right side. That's basically standard form. It is important to note you can have fractions in standard form. I just did not want to deal with the fractions, so I multiplied both sides by 4. But it's kind of optional. You don't really need to do it. The next thing here, find an equation of the line with y-intercept 0, -4 with the slope 2/3. All right, so it gives the y-intercept, so I'm just going to do this in slope-intercept form. So it's going to be y equals mx plus b. This is basically what slope-intercept form is. We're actually going to talk about it in the next section, but because it's given the y-intercept right away, it kind of makes sense to do this one in slope-intercept form. So all you have to do is plug in the slope, that's the m right here, is going to be 2/3, and the b is just whatever the y-intercept is. In this case, it's -4. So you basically can write that as the answer, y equals 2/3 x minus 4 or plus -4. It doesn't really matter. Now, if you wanted to, you could do point slope on this. So y minus the y that's given is equal to 2/3 the slope times x minus the x that's given. Okay, this becomes a plus. I'm going to subtract 4 on both sides, distribute that 2/3, and you'll notice you get the exact same thing, 2/3 x minus 4. Okay, so if you do point slope form, that's fine. That's the yellow basically. Or you subtract that 4 over and distribute out that 2/3. You end up with the same answer for each of them. Doesn't matter which form you do, you will always get the same answer. It does not specify which one to do, so I would just do the easiest one whenever they don't specify. All right. In the last example, you may notice something interesting. When a linear equation is written in the form y equals mx plus b, we can immediately read off the slope and the y-intercept. I kind of talked about that. An equation in the form of y equals mx plus b is called slope-intercept form. It's usually the go-to because you can easily, imagine what the graph looks like from slope-intercept form. It might not be the fastest to solve for each time, but it's better than standard form, and point slope form is probably the fastest to solve for, but it doesn't tell you exactly what the graph looks like just by looking at it. Not as intuitively anyway as slope-intercept form, but let's do some example problems of getting into that y equals mx plus b format. So it says rewrite the standard form equation 4x minus 2y equals 14 in slope-intercept form. First thing I'm going to do is simplify everything as much as humanly possible, so I'm going to divide everything by 2. Okay, it just makes the problem easier to look at. Then determine the slope and y-intercept of the line described by the equation. Okay, so from here I'm going to solve for y, so it's in slope-intercept form. So I'm going to add y to both sides and subtract 7. And you're going to end up with 2x minus 7 is equal to y. And that is the slope-intercept version of this line. So it says rewrite it. That's the first part of the answer. Rewrite in slope-intercept form. So I'm going to color code that in there, highlight it. Then determine the slope and y-intercept. Okay, all you have to do is look at the equation and go, oh, the slope is 2 because it's whatever's with the x is the slope, and the y-intercept, the b, is just -7. So you can just look at that and know exactly what the slope in the y-intercept is. That's why it's called slope-intercept form. And that's basically the answer for that question. The next one, a line with y-intercept 0, 2 passes through another point 1, 9. Find point slope form of the equation of a line and then also write it in standard form. Okay, so again, we're not given the slope, so we have to figure out the slope for this line first of all. So let's see here. I'm going to subtract the second y from the first y divided by the second x minus the first x. And then you're going to have 7 over 1. So the slope is 7 for this problem. Point slope form is y minus one of the y's that's given. I'm just going to do 2 because it's easier. And then equals the slope times x minus one of the x's that's given. And it has to be the one that corresponds with the 2. So if I use the 2, I have to use the 0 because those are linked with that coordinate. All right, so from here, it says point slope form. So that's the answer for point slope form. I can simplify it a little bit. That's still considered point slope form because the x is 0 over there. And then for the next part, put it in point or standard form, sorry. And then, so that I'm going to subtract the y on both sides, and you're going to get 7x minus y. That is the standard form version of it. It's also important to note that you could have, if you really wanted to, you could have subtracted the 7x and added the 2. And if you did that, it would have been y minus 7x equals 2. And if you notice, it's just the exact opposite of the blue with the signs. Everything's the same, but the signs are different. The y is negative in the blue, but positive in the y. The 7x, it's negative on the purple, and in the blue, it's positive, and then the 2's, it's negative in the blue, and the purple, it's positive. So it just flips. Either one of those would be acceptable as an answer. So. Okay, next thing, a line passes through the point 2, -5 and is perpendicular to the line described by y equals 2x minus 4. Find the equation of a line. So we need a perpendicular line. That means we need to figure out the perpendicular slope. The non-perpendicular slope is 2. So the perpendicular slope, this is the symbol for perpendicular slope there, it's going to be -1/2. So now you know the slope of that other line that we're trying to look for, and we know it goes through this point here. I'm going to do point slope form, so it's going to be y minus whatever y is given times -1/2, that's the slope, and then x minus whatever x is given, and that is your final answer. You can simplify the negative, of course, and you end up with that for the answer. All right, 7, don't forget about horizontal and vertical lines. Find the equation of a horizontal line that passes through the y-intercept of the line y equals 5x minus 8. Well, the y-intercept is -8, so that means the y is equal to -8. If the y is equal to -8, then that's the horizontal line. So the equation of the horizontal line, if it's going through -8, it has to be y equals -8, and that's the answer for that one. Not too exciting. Number 8, an engineer working with a certain voltage-controlled amplifier finds that an input, so an X, of 1.32 volts is amplified to 14 volts, while the input of 3.79 has an output of 8 volts. So input is the X, output is the Y. Assuming the gain is linear, find an equation relating the input and output voltages. So we're just looking for an equation of a line here. Well, we need a slope for the equation of a line, and then we can put it in point slope form. It doesn't say which one to do, so that's what we'll do. So first thing we're going to do is we're going to find the slope. So right now we know the X is 1.32 and it's linked to the 14.00 for the output. And the other one is 3.79, 8.00. We're going to subtract the Y's. I'm just going to do 14 minus 8 is 6, divided by the 3.79 minus 1.32. You divide that out, you're going to need a calculator probably, and you get 2.429. If we're rounding to 3 decimal places. It doesn't really say, but it's just a safe bet to round to 3. So then I'm just going to do this in point slope form. Y minus the y that's given, one of the y's that's given. I'm just going to do the 8 here because it's easier number, it's a smaller number, times the slope, 2.429, times x minus the x that's linked with the 8, 3.79, and you end up with something like that. And that's basically the answer for that one. And you can see we kind of just used the same kind of thing, the point slope form, the linear equations to figure out that one out. All right, so that is equations of lines in special forms. We went over slope-intercept form, point slope form. We went over how it relates to parallel and perpendicular lines. And then we did an example problem, a real world problem. If you have any questions about anything in this video, let me know.